Just looking through our online inventory, I noticed this DEV 8:1 L-band combiner. I didn't remember that we had it, and so I thought I'd go back, pull it out, look at it, and see exactly what it does. So that's what I'm going to do this afternoon. Just look at it in more detail. Beneath there are two Comtech 570L modems. They are both generating L-band signals. But before I get to that, let's go and look at the back of the DEV combiner. The connections challenged me a little bit because the output from the Comtech 570L modems are both type N, but the DEV 8:1 splitter combiner needs SMAs. So I had to go into my little box of tricks and see if I could get the N to SMA converters. And I did, and there they are in place. So as you can see on the bottom row, that's the L-band output from two modems feeding into the combiner ports 1 and 2 on the top, and the black cable, this one, is going straight out to the spectrum analyzer so I can look at the combined signal from both these modems. One point that I forgot to mention, the DEV combiner has a dual power supply. That's particularly good if it's in a critical situation. What I did, I set up these two modems in an identical configuration, well, except for the frequency, obviously. For example, modulation here is QPSK, modulation down here is 8PSK. I'll get to the difference in a minute. The code rate on one modem is 7/8. Code rate on the other is also 7/8. Now let's look at the data. The data there is 3750, and on the bottom one 3750 as well. So with the exception of the frequency, everything is pretty well identical, except we're running QPSK on one and 8PSK on the other. So what does that mean? Normally when you go to the higher order modulation, they're more efficient. And if they're more efficient, it means that you use less bandwidth. And I think this is very clearly shown on the spectrum analyzer for these two signals. The fatter one is the QPSK. The one that's slightly slimmer, more efficient, is the 8PSK. And of course, if this particular modem had 16 QAM, that would even be slimmer. And when you're buying bandwidth from the satellite operator, this is what you're buying. So the smaller your signal, or the smaller the footprint that it takes on the satellite, the less you pay, the more efficient it is, and the lower price you can charge your customer, or the greater profit you can put in your pocket. So this is quite a simple unit. The DEV L-band combiner seems to work fine, no problems, and that's about all I can say about it. See you on the next video.